realize it's possible to not have nice pretty numbers on everything you do. Okay. So we're starting out with talking about what it means to be tangent to a curve. If a line is tangent to a curve, that means it's just touching that curve. Okay, it should have the same general direction as our curve. So I put a picture on your slide. At this point right here, this pink line is tangent to the curve at point P. That means it's just hitting that curve right there and bouncing off. It doesn't go through. Now, eventually it may intersect the curve later on because the curve can change directions. But at that particular point, it's just touching the curve. So we can see like this line has a positive or negative slope. Negative slope. If you're looking at the curve, where you're at on the curve, that curve is decreasing right there. So the tangent line gives you an idea of the general shape of your curve. Now, one of the big things we're doing this semester, we are leading into this concept of a derivative. And a derivative has everything to do with tangent lines, because a derivative tells us how things are changing, and that tangent line gives us that first clue about how it's changing. So we're going to start out today just writing equations for these tangent lines. So here I have a parabola, y equals x squared, and I want the equation of the line tangent to it at the point 1, 1. We all know what a parabola looks like at this point. Now here is the line I'm looking at. So my tangent line's a little off, but I'm trying to write an equation for that tangent line. Now, the idea is we know how to write equations. We need a point and a slope, correct? We have a point on that line. I am going to have to get the slope of that line. Now, as time goes on, we will learn better methods for doing it. But right now, we're just trying to get a basic understanding. So we are going to have to estimate that slope. So we are going to make a table of values here and see if we can predict. So we're going to do x, y, n. Okay. How many points do you need to find a slope? 2. So I can't just, I have one point here. We need to pick another point. Now if I pick the point like negative 1, 1 and calculate the slope between those, is that going to be close to the line I have? No. If I picked 0, 0, and 1, 1, would that be close? Closer. Probably still not amazing, is it? We are going to pick some x values getting closer to this curve and see if we can estimate what the slope is based on this trend. So I'm going to start, let's just start with the next value of 0. Okay, 0 squared is 0. So if you estimate the slope, y2 minus y1 over x2 minus x1, we get a slope of 1. But we know that's not the true slope. If I wanted to get a better idea, what would I do to my x values? They would need to get closer to 1, wouldn't they? So let's pick something closer to 1. Let's say I did 1.5. So 1.5 squared is 2.25. And then you can do your slope. Y minus y over x minus x. And what do you get? Hmm? 2.5. Okay. So right now we have found our slope here, and from 1.5 was using this point here. Okay, does that show me any general trends yet? Can you estimate what it is from that information? Not really. So if we're just picking points haphazardly, yes, 1.5 is closer to my point than 0 was, but I'm still not getting a trend. A lot of times what I would recommend doing, what we're going to look at, is making two separate tables. We are going to do one table for numbers that are smaller, and then one table for numbers that are bigger. So for instance, we might move this one down to a second table and say, okay, well that one's bigger than my point. And then stick only with numbers that are smaller than this point over here. So maybe I'm going to try to put in 0.5 or 0.9 and estimate these slopes. If I'm looking at things bigger, I could do 1.5, or what would be something else that's getting closer to 1 but bigger than it. 1.2, 1.1. Those things, they are getting closer to 1. So what we're doing here is we are actually approaching this one from two different directions. We are approaching it from the left, the smaller side, and we are approaching it from the right, the bigger side. Okay, let's calculate these slopes real quick. So this is where the calculator can come in handy. So if you put in your 0.5, 0.5 squared, do 0.25. Let's just divvy it up so we're not. But you girls do 0.5, you three do 0.9, you two guys do 1.2, and you two do 1.1. So find your slopes there for me. Slope. What did you say? 1.5. Okay, when we put in 0.9, so you do your 0.9 squared and you get 0.81. And then when you did your slope, y minus y over x minus x, what did you get? So you're doing your 1 minus 0.81 over 1 minus 0.9. What did you guys get for that slope? That was my second row of people, I believe. Did you get it? Yeah. The 1.2 people. So you did your 1.2 squared, because our equation is just y equals x squared. If it were like y equals x squared plus 3, then you would do 1.2 squared plus 3. You're just plugging it into your equation, so you get 1.44. And what did you guys get for your slope? Kate and Ethan, what did you get there?
It's probably wrong.
Just,
Wait, is it 1 minus 1.44?
yeah, you can do it that way. So, and then you would have to do over 1 minus 1.2. Because 2.2? Okay, the 1.1 people. You put in 1.1, you get 1.21. And what did you get for your slope?
2.1.
Okay. Are there questions on how I'm getting my y or my slope? Basically, in all of these, the slope, we are looking at the 0.11 and whatever order pair you got. And then we're doing change y or change x. So the whole idea here is we're trying to figure out what the slope is approaching. My general rule when we're making these tables, we have to do a minimum of 3 points bigger and 3 points smaller. So a total of 6. Now, if you can't tell your trend from here, we could do more. Now, if you want to get closer to 1, you could do 0.99, 0.999. Or this way, we could do 1.01, 1.001. You can always do more points. Can you tell what this is approaching? What do you think? Maybe a 2? Does this one? Maybe, and if we keep doing more, I think we can say in general it's just going to keep getting closer to 2. These two numbers should match. We have to check both directions, but you should see the same trend from them. If your trend isn't obvious, we can pick smaller points. What we see from this is both of these are approaching 2. So we can guess, we are not 100% certain, but we can guess that the slope of this is 2. So now, and I think I put blank slides next to each of these to give you guys a little more room to work, we need to write the equation of our line. So we are looking at the point 1, 1. We are saying the slope of our line, we are guessing it to be 2. So now you can plug into y equals mx plus b. And we get our b to be -1. So y equals 2x minus 1. That is the equation for that tangent line when the curve is y equals x squared at the point 1, 1. So if I picked a different point on that curve, it would be a different tangent line. Okay, this one is unique to that curve and that point. Okay, questions? Yes, ma'am. Other questions? So right here, we were estimating the slope of the tangent lines, but to do that, we were actually using the secant line. A secant line is a line that intersects a curve. Because my tangent line just had 1 point on the curve, we had to use lines that would have 2 points to guess what our slope would be. In general, what we just did there by looking at the tables and estimating our value, that is what is called a limit. And we are going to spend a lot of time in this chapter talking about the idea of a limit, what it means. We will get to shorter ways of calculating the limit. But this is a really good way for trying to understand what it means. So we say that the slope of the tangent line is the limit of the slopes of the secant lines. Okay, how we see that is the limit as our x value got close to 1 of the slope, right? If you think about those slopes, we had the point 1, 1, and then we were taking an x, and when we plugged them in to get the y value, we did x squared, right? So if I calculated my slopes, it would be like x squared minus 1 over x minus 1. So the limit of those slopes, and when we worked that out, we found that to equal 2. That's our first taste of a limit, first idea that we've seen about what a limit actually means. The next slide, I put some pictures just to try to help you understand a little bit more what we were looking at. So this pink line here is our tangent line, and the blue line is representing a secant line. So what we did is we would take that Q and we would make it get closer and closer to P. And you can see as you do that, that blue line is getting closer and closer to the pink line. So the closer together these two x's are, the closer together those lines will be. And that's how we use it to estimate the slope. All right. Questions there? cardiac monitor is used to measure the heart rate of a patient after surgery. It compiles the number of heartbeats after T minutes. When the data in the table are graphed, the slope of the tangent line represents the heart rate in beats per minute. The monitor estimates this value by calculating the slope of a secant line. Use the data to estimate the patient's heart rate after 42 minutes using the secant line between the given values of T. Okay, so this is telling you how many heartbeats you have at a certain time. We are going to use this to calculate the heart rate. We are going to do several calculations, and I think we might just divvy it up and try these so everybody gets a taste to try it. I'm giving you two different T values, and what am I asking you to calculate between them? The rate, the slope. So y2 minus y1 over x2 minus x1. The heartbeat is like your y, your time is like your x. Okay? So let's just do the same groups that we did before. So you two ladies do A, you three do B, you two do C, and you two do D. What I've given you guys, these T values, those are like the X values. So you could write order pairs, 36, 25, 30, 42, 29, 48. And then now all I'm asking you to do is that slope calculation between them. Y2 minus y1 over x2 minus x1. So what did you guys get for the slope of the first one? 6. Do you agree with that? So you would do 29, 48 minus, oh, 25, 30. Okay, that would do it. All right, B. What did the second row get? C, third, or you two guys over there in the corner, what did you guys get?
71.
Okay, and D. All right. So we are trying to now look, if you notice these four all had one thing in common. The 42 was consistent with each of those, right? So we could see when our heartbeat, what's it doing? It's going kind of fluctuating, isn't it? It started out going up and then it started going down. So any general conclusions? You could say if it was all increasing, you could say it was increasing at the same time. Really all we can say is it's fluctuating between 66 and 71.75 beats per minute. Okay, there was no obvious pattern there. It wasn't like the one that we did before where the numbers just kept getting closer to 2. Questions on that? For the time being, I'm going to skip this example because it is a 100% calculator problem. There is no way I could ever make that pretty. It's just plugging in the calculator. So we may come back to that. I'm going to skip it for now. I want to talk about velocity. So this idea that we are talking about, these tangent lines, these secant lines, very, very closely related to our velocity. One thing I should maybe give you, the general velocity equation. This is the equation for height after a given time. is in meters per second. So there are a couple variations of this we are going to use. Sometimes we would use like a 16 t-squared if we were talking in feet. This is an equation that right now I'm going to give you. Eventually we'll see it enough that it's not going to be an issue. But for now, if I want you to use this on test, I would say in parentheses use this equation. Alright. Suppose that a ball is dropped from the upper observation deck of the CN Tower in Toronto, 450 meters above the ground. Find the velocity after 5 seconds. Okay. Velocity is what? Velocity, what does that mean? It's just like speed with direction to it. It can be positive or negative. This one, our ball is falling. Okay, we are trying to basically find how fast is the ball. That's all we're looking at here. So what we could do, this equation, since it's falling, can we just make this a negative? Usually if something's going up, we use the positive version. If it's falling, we make it a negative. Again, I would be giving you that equation. So if there are a couple different ways we could think about this. If we want to simplify this the most. V sub 0 is your beginning velocity. If you are holding the ball, so you're not actually throwing it with any force, you just hold it and drop it. What's your beginning velocity? 0. It's starting from rest. Our beginning height, we could do it one of two ways. We could do it with a height of 450, or we could essentially call this height 0 and measure it that way. And for the calculation we are going to be doing, it's not going to matter. So let's just say our beginning height is 0. We're going to say the top of the tower is a height of 0. Because all we're concerned with is the speed, so it's not going to be important there. So we are just going to use the simplified version of the equation. Our height is negative 4.9 t squared. What we are going to do to estimate the velocity at this one particular point in time, we are going to look at velocities between 2 points in time and try to estimate them. So, let's say time. So we're going to have to take 2 time intervals. What is the one time interval I'm really concerned with? 5. So if I were to plug that t in, so I would have negative 4.9 times 5 squared. We get negative 122.5. So that is the point. We are going to find the slope between all of these and that point. That is our fixed point. Okay. If we want to look at this, let's just say we did between 5 and 5.5 seconds. Okay, if you plug a 5.5 in, then to find the velocity between these, this is just slope. So you're going to do y2 minus y1 over x2 minus x1. So just our slope calculation. I got negative 51.45. Do you guys agree with that? That's how I got it. So I did just the slope calculation. So these are my y values, so y2 minus y1 need to do some more. So getting closer to 5. Let's say I did 5.1. So if I plug a 5.1 in, I get negative 127.449. So now you're going to do slope between this point and this point. And I get a slope of negative 49.49. Okay, is it obvious yet what it's approaching? Probably not. Let's go closer to 5, so maybe 5.01. Plug that into your equation. That's your y. Now you do the slope between these. Should get negative 49.049. Okay, can we tell what this is approaching? Maybe what does it look like? Negative 49. If I wanted to be really sure, we would need to test some points from the other direction, so things smaller than 5. So maybe like a 4.5, 4.9, 4.99. So let's test these. Kayla, you guys do 4.5. Why don't you two and Danny do 4.9, and you two and Cole do 4.99. Plug them in, get the y, find the slope. So my 4.5 people, just tell me what did you get for the slope, the velocity. $4.9 people, what did you get?
Oh, wait, I was giving you that.
Oh, okay. I thought that was really off. I was a little concerned.
Yeah, 46. No, it's really
Okay, sorry. I just want the final on the slope. What did you go?
I got negative 48.1.
All right. The 4.99 group, what did we get? So, does this also look like it's approaching negative 49? So the question was to find the velocity of the ball after 5 seconds. We checked numbers smaller than 5 and bigger than 5. It appears that they are both approaching the same thing, so we could assume our velocity is negative 49 meters per second. Again, it's a negative because it is falling. Velocity is just speed with direction to it. All right. Questions there? So this leads us into the idea of the velocity. We talked about, like with our first graph, we were trying to find the slope of a tangent line, and we used our secant lines to do that. Instantaneous velocity is just velocity at a specific point in time. zigzag for 5 seconds. I'm asking you for instantaneous. At that 5 seconds exactly, what is the velocity at that time? That's like your tangent line. So we are sometimes going to have velocity questions, sometimes I'm going to ask you just secant tangent line questions, but they are the same question. Slope of a secant line is the average velocity. So when we're finding those slopes between two different points. Slope of a tangent line, that is one particular point in time. That's our instantaneous velocity. I'm going to go ahead and do the last example and just finish this up. A rock is thrown upward with a velocity of 20 meters per second. Its height in meters t seconds later is given by this equation. So there's our equation that we're going to use to find our y values. Part A, find the average velocity during each time period. So I'm going to do the first one with you and then we're going to have you guys try something. What this is not an ordered pair. This is a time period. It's saying between those. So it's saying 1 is an x value, and then 1.5 is an x. How am I going to get the y values that correspond to those? Plug them into the equation. So 20 times 1 minus 16 times 1 squared, and that gives us 4. Okay, when I plug in a 1.5, I get negative 6. So those are two ordered pairs. I am asking for average velocity is just the slope between them. So y2 minus y1 over x2 minus x1. Of negative 20 meters per second for that time frame. Okay, let's divvy it up and do. So second group, what did you guys get for your slope? All right, next group, what did you get? Group. You guys even do it over there? Yeah. Fine. It came out, depending on how many decimal places, I think it comes out to be like I think 12.016 if you want to keep a few. So from this, if you look, each of these x values is getting closer to 1. 1.1, 1.01, 1.001. So part B says estimate the instantaneous velocity at 1 second. So if we look, instantaneous velocity is just at one particular point. So we have to look, what is this approaching? Negative 12. So our instantaneous velocity at that one particular time is negative 12. Alright. Questions? It's tedious work, but it's not necessarily difficult. It's plugging numbers in your equation, you get your y, and then doing slope over and over and over again. The assignment is twofold. There are 3 book problems, and then there is a handout that I'm posting on Classroom. We will have a workday